Okay. I'm Don Wuebbles, a professor at the University of Illinois. I'm here to talk about the Climate Science Special Report. First of all, I want to thank NASA for inviting us to give a talk in front of the Hyperwall. And on November 3rd, we released, through the federal government released, through the U.S. Global Change Research Program, the first volume of the fourth National Climate Assessment, which is called the Climate Science Special Report. I was one of the three coordinating lead authors. And for anyone who would like it, David Reedmiller is hawking copies of the, well, here he is, of the executive summary for anyone who wants it. I'm surprised he's not saying, you know, some kind of beer thing he's doing this. There he goes. Anyway, so this report is an authoritative assessment of climate change with a focus on the United States. It was co-authored by over 50 authors. It went through a very extensive review process. 6 major levels of review took place, including the National Academy of Sciences, public review, and a number of reviews by all of the major government agencies. And in the end, the U.S. government let us release it. So that was quite a doing. So let's move on and talk about some of the findings very quickly. First of all, our climate does continue to change. It's changing very rapidly. We've seen about 1.8 degree increase in Fahrenheit increase in temperature, 1 degree centigrade, since 1901 through 2016. Most of that change occurring in the last 60 years. And 2016 was the warmest year in record, but it's followed by 2015 and then 2014. So the last 3 years have been extremely warm. As we look at 2017, it looks like it's going to end up second or third on the list because we're in a slight El Nino year. The surface temperature globally has increased, particularly over the land. This graph doesn't show it very well, but there's only a few places in the world where we're seeing any decrease in temperature. One of those being off the coast of Greenland, where we're getting fresh water into the Atlantic Ocean, which is slowing down the circulation and having an impact on ocean temperatures. Next, please. This is a little movie looking at the temperature changes over in terms of 5-year global temperature anomalies from 1880 to 2016. This is done by NASA. And we'll show you a little bit more about the kind of changes we've been seeing over this time period, particularly as we get up to the present. We'll see the very significant changes that have happened in recent decades. There are many other aspects of the climate system that are changing, and next I'm going to try to go into those as soon as we complete the film. Well, let the film go. Sorry. Well, it was going to show you even more bright oranges and stuff, so forth. But there's many other aspects to that. If we look at ENSO events, El Nino and La Nina events, we find in both cases the temperature overall are increasing as well as in the neutral phase. Sea ice is decreasing, as Jack Kay just talked about extensively, so I won't go into that very much. But we're also seeing extensive decrease in ice throughout the planet, and this just shows Greenland and Arctic ice sheets decline over time. Next, please. So this is a film of the sea ice, much like what Jack just shows you. I'll let it go through that very quickly, and then we'll move on. But basically, we are seeing a significant decrease in Arctic sea ice over time. But it's not only the area; it's also the volume of sea ice is decreasing quite dramatically. And so it's expected over the next 20, 30 years or so that we will reach a point where there is very little ice in the summer in the Arctic. Okay, next, please. So this shows that the very high percentage of the extra heat, the reason for the changes in climate are primarily because of human activities and the increasing amounts of carbon dioxide, methane, nitrous oxide, and various particles. And but about 93% of that heat is ending up in the oceans. And so it's actually only a small amount that's actually leading to the kind of climate effects we've already had. So if the oceans become saturated at some point, then we're going to see much, much faster climate change. And so that data is quite dramatic. Next, please. Looking at turning to extremes. So it's not just temperature change that matters here. What really is going to matter to humanity is what's happening to severe weather events. And in this case, we're looking at daily temperature records as an indicator of what's happening to significant increase in heat throughout the world, but we're seeing it in the US as well, where we're having more heat records than cold records in recent decades, showing that we really are having a significant impact on where we live. Next, please. Likewise, for precipitation, more precipitation is coming as extreme precipitation. What this shows is the 99th percentile level of precipitation change from the 1950s to now, and basically shows a significant increase over everywhere in the continental United States, even where it's tended to be drier in the Southwest and Southeast in general. But we're particularly seeing that in the Midwest and Northeast, where we're seeing a significant increase in extreme precip. And that has an effect on agriculture particularly, but on many other things as well. Next, please. So this is showing other aspects of extremes, particularly in this case, wildfires. You've all heard about what's been going on lately with wildfires, but in general, we've been seeing an increase in the amount of acreage for wildfires, and also the rising cost of what that's meaning to the American people. I don't think I have it in this talk, but in general, the changes in climate are already impacting our pocketbooks. It's having a huge impact in terms of effects on, because of the effects of severe weather changes affecting our society, and it's affecting our money we pay in taxes. Thank you. Next, please. So one of the other aspects is the first time in an assessment we really talk about the aspect of what are called atmospheric rivers, where you have concentrated air masses bringing lots of water vapor, and in this case into California, which led to the breaking down of the drought situation in California earlier this year. This is from, I think, February 17th, and basically can bring a huge amount of water vapor. Of course, it leads to floods, as well as helping deal with filling reservoirs and so on and so forth. And we expect such type of things to increase in the future. So more atmospheric rivers are expected. Increasing trend in atmospheric rivers. Next, please. Okay, so let's turn to sea level rise. So far, we've seen about 7 to 8 inches of sea level rise globally over the last century plus, since 1901, and or in the 1800s. And as we look into the future, we're seeing an acceleration of that change. About half of the change has occurred since 1993, a little under that. And as we look at the coming decades, we expect another 1 to 4 feet relative to now increase in sea level rise globally over this century. And this is the fastest rate of change in over 2,800 years, based on data that we have going back in time. One of the really scary aspects of this is, though, that because of the We don't really know what's happening in West Antarctica very well, that the sea level rise could be as much as 8 feet by the end of the century. But there's a lot of uncertainty in that, of course. Next, please. This is showing that there's lots of other issues associated with that. One is we're seeing a lot more nuisance flooding happening throughout the country in coastal areas. And most coastal areas of the country are having this problem, where we've already seen a significant increase in the amount of coastal flooding, where streets are being flooded on certain days when there's a high tide. And you can see here for 3 examples of different cities across the country how many, the percentage increase in such floods. And it is having a cost, again, to the American people because of this happening. Next, please. So why is this happening? Is because, as I mentioned earlier, because of the increase in carbon dioxide, if we look at future scenarios for sea level rise and say, well, what could this mean in terms of looking at various places around the country? By the end of the century, we could be, in this case, for 4 degrees centigrade increase in temperature, the kind of thing we might get with a high scenario. We got significant amount of Washington, D.C. is underwater. And we're going to have to deal with that. Even with 2 degrees, we still have a significant impact in certain places. Be fun getting to the football stadium or baseball stadium, whatever that was. Why don't we go on? I don't have much time. I got 2 minutes left. So one of the aspects we did in the Climate Science Special Report was to look at the radiative forcing, the change in the forcing on climate that has happened since 1750 due to human activities. And volcanoes would cause a slight cooling. They put sulfur in the atmosphere, and it turns to sulfuric acid aerosol that causes a cooling. But it's a very small effect over that time period. The sun has really not changed much. Very, very slight increase over this time period. It cannot explain the temperature changes we've seen, whereas in fact, the human activities has led to this very significant increase in radiative forcing that explains almost all of the changes we've seen, particularly over the last 60 years. Go ahead, please. Next. Well, we also looked at future scenarios in the report, looking at future emissions for carbon dioxide, methane, et cetera, of the greenhouse gases and various particles, and then look at the resulting impacts on temperature, about the way present emissions would be comparable to the high emission scenario, which would suggest 8 to 10 degrees Fahrenheit increase by the end of the century. That may not sound like much, but if you look at the last ice age, this is a significant fraction of that in the opposite direction. So it really would have a huge impact on society. The best case would be if we can try to get down to holding the changes to about 2 degrees, which would be this lowest scenario, which is called RCP 2.6. And that's going to be difficult to do, but that is the aim. One of the aims of the Paris Agreement is towards eventually getting to that. Next, please. I got 9 seconds. So I want to thank again all the different agencies that contributed to this, plus my many colleagues across the nation. The authors represented the government, academia, and industry. And I really thank them all for the hard work they put into this. Thank you.